Well, hello everybody. It's Rob Berridge here, Rob here. Hope you're all doing well. I'm starting to do some tutorial videos, some for free, which this one will be on YouTube, of some various thoughts that I've had, and they're going to be coming on for some sort of time now. I'm going to be doing quite a lot on Academy, as I said the other day on a previous introduction video. I'm not going to show my face in these videos because, frankly, I hide away from mirrors as much as I possibly can at the age of nearly 59. So. And I'm sure everybody that knows me can respect that. So I'm just going to try and make it as light-hearted and as enjoyable as possible, but give you some ideas on how I do designs. And a lot has changed in the last, I would say, year or so, something like that, of my thoughts on system design. And I've been speaking to quite a lot of people about the idea that I'm not as convinced now that a room-by-room heat loss calculation is absolutely as necessary as we think. I think a whole house heat loss calculation is almost sufficient, but I'll put some meat on the bones on that and explain why I think that. And I'm sure that just put some comments in below and say what you want to do and open up the debate. I'm not witch hunting anything or anything like that, because I 100% believe in the idea of heat loss calculations. I think they're imperative to do. But what I want to try and ascertain is that for low temperature heating system design, the most important criteria, in my opinion, is water volume within a system. Now, those of you that know me reasonably well and they follow me on social media and that kind of thing will know that I've been sort of promoting the idea that between 17 and 20 litres per kilowatt is the Goldilocks zone for system volume. And I wanted to try and put some meat on the bones of that and show some slides of what I've worked out and how you can do it yourselves and get the idea of this working really, really well. I would say 20 litres per kilowatt if you can, because the lower the flow temperature we can get, obviously the more volume you're going to need in order to maintain or reach set point within the building. And that might be 21 degrees, 22, whatever it is that you want to do. So if we get started, I will just say that I've just spent a little bit of time on the telephone with Apple, because I run Macs and iPhones, asking them how I can use their QuickTime Play, which is what I'm recording on this, but then also bring up my phone screen in real time on top of the screen recording that I'm doing, so I could actually demonstrate the absolute fabulous IMI Hydronics app, which I use every single day in a professional capacity in my career. But unfortunately, I can't do that, so I've had to take a screenshot of what is going on. But I will do, once I'm able to work that out, I will do a tutorial on the app of various other things. I did do one a while ago on another platform, but hey, that's the thing. So putting some meat on the bones with this, I spoke to Stelrad radiators and Ultraheat radiators, and I asked them for their water content or water content within the actual radiator systems themselves, and they kindly sent me through the charts that is needed. So I'll show you those in a minute. You can screenshot them or just keep this video because obviously it's free to see. But so what I did, I went into the fabulous IMI Hydronics app and I made this system up. Now, I'm looking at a kilowatt, so I've got as close to a radiator sizing as I possibly can there. You see it's just about a kilowatt, 1.00153. And I ascertained I'm looking at a nice low flow temperature of 40 degrees and a return temperature of 35. So that's a mean water temperature of 37.5 degrees. Yeah, and we'd all agree with that, and that's at 21 degrees room temperature. To get that, I played around with the app of different sizes here to get down to my output of 1 kilowatt. And I've established that it's a 700 millimeter high, 2.2 meter long K2, type 22. So that's 2 panels, 2 convectors. So type 33 would be a K3, type 11 would be a K1 for argument's sake. That's people don't understand that. So we can see that it's 2.2 meters long at 700 millimeters high. That gives us 1 kilowatt. So if we now go to the radiator sizing of Stelrad, this is a particular one, and again, this is really important that you do these calculations with EN442 because the content should be about the same. So we're looking at a K2 radiator here. There's your water content in litres per metre Don't confuse that with litres per minute, litres per metre. And you scroll across and we've got 7.63 litres per metre within that size of radiator, 700 mil high. Now we said we wanted 2.2, so if we pull up our calculator and we say 7.63 times 2.2, and that's where I got the 17 litres from per kilowatt. So I've rounded it up. A little bit more water volume is not going to cause a problem. Now my point of this is this: if you're talking about 17 litres per kilowatt, add on for your pipe work throughout the system that you're designing, and that's why I say between 17 and 20 litres per kilowatt. I would argue that 20 litres is probably a better amount, and it's going to heat up this time, and that's running at a lower flow temperature. So if you change on the IMI app, if you change the flow temperature to the one that you've got desired, I would obviously try and do it as much as you possibly can. I would say there are two items within a heating system that you cannot oversize. One is radiators and the other one is expansion. And obviously that's a completely another subject which I'll come onto on another tutorial video, or even through a probably an hour or two's training, because there's a hell of a lot to learn on the expansion. But you can see exactly what I'm trying to ascertain here. Now, if you've got a 8 kilowatt system, for argument's sake, 8 kilowatt heat pump that's going in, and you put that 20 litres per minute, you're going to want 160 litres within that whole system. So what if you only have, I don't know, let's say 100 litres in the system? Then you're going to need a 60 litre volumizer to get it up to that point. And I think this is where you can size volumizers correctly to get it exactly to that 20 litres per kilowatt of requirement. And I don't really need to go much further with that explanation to make sure that you can see the reasoning behind what I'm trying to do. And literally, when it comes down to the sizing of the radiators within different rooms, as long as you are placing a load compensation device in a very decent place, so out of direct sunlight, out of any direct heat source or anything like that at all, literally allow the compensation control to balance down. The only time I would say that you would need TRVs, like the IMI TRVs you can use, is if you've got rooms with solar gain, or you are experiencing overheating of certain rooms because of your litres that you've put in. Again, a room by room heat loss calculation would negate that, but as long as you can get the volume up, that's the point. The idea, the more volume of water you have, the lower the flow temperature you can actually get running through the system, which is exactly what we're trying to do. So I keep saying it before, we don't have an energy crisis, we have a wastage crisis, and sometimes a bit of a design crisis. So I really, really hope you enjoyed this video. If you do, please give it a thumbs up, and please subscribe to the channel. The more subscribers I get to this channel, the more I can actually, if I can start to monetize it, then I will do all of these for nothing, and I won't be putting anything through Academy as I stated before. So many thanks, and see you again soon.